Alright, so this is page 257, number 22. So they give us this drawing, and they tell us the equation of this curve that I drew very poorly is quantity 2x minus 3 to the power of 3. And then there's two parts. So part A says, find the x-coordinates of the 2 points on the curve which have a gradient of 6. So what you'll remember is when you are told that there's a gradient of 6 on a curve, the gradient occurs when you have the derivative. So this is just asking us to find the derivative. So just as a refresher on the chain rule, y prime is equal to 3. So I drop my 3 down, times 2x minus 3 with my new exponent of 2, right, because I subtracted 1, times the derivative of the inside, which is 2. So my derivative is equal to 6 times 2x minus 3 squared. Now they're saying they want us to know which 2 points on the curve have a gradient of 6. So since the derivative itself is the gradient, all I'm going to do is substitute 6 in for y and solve for x. And I know I'm going to have 2 results because I have a square here. So I'm going to divide 6 on each side. So I'm dividing 6 off, so I get 1 times quantity 2x minus 3 squared. Okay, taking the square root of both sides, I get plus or minus 1 here equals 2x minus 3. I'm going to add 3 on both sides, and that makes that go away. So I have 3 plus or minus 1, and then my final step is to divide by 2. So let's see my 2 answers. So one of my answers is 3 plus 1 is 4 divided by 2 is 2. My other answer is 3 minus 1 is 2 divided by 2 is 1. So that is part A. Alright, so let's go back and do part B. Okay, there we go. So now part B says, the region shaded in the diagram is bounded by part of the curve and by the 2 axes. Find by integration the area of this region. So the first thing we know is since it's bounded by both axes, one of our x values is 0, 0. The one we don't know is this one. So what we're going to do is, by definition, if something's on the x-axis, y has to equal 0. This is part B. Okay, apparently my pen is not working. So 0, and I'm going to go ahead and solve for my intercept. So the cubic root of 0 is 0. So I end up with 2x minus 3. So I'm going to add 3 to both sides. I'm going to divide by 2. So x is equal to 3 halves. So my other x-coordinate, we could say, is 1.50 or 3 halves 0. Alright, so continuing on with part B, we need to find the area of this curve. And we know since it's underneath the x-axis, we're going to end up getting a negative value. Area can't be negative, so we're going to take the modus or the Skittles, or the absolute value of that. So let's integrate. So we're traveling on the x-axis from 0 to 1.5. So we're going to integrate. And we're integrating quantity 2x minus 3 to the third times dx. Alright, so we are going to use our little rule for integration here. So what we're going to do is we're going to say 1 divided by our a value, which is 2, times my the integral of the outside, which is 1/4, times 2x minus 3 to the 4th. And we're going from 0 to 1.5. Alright. Oh, look, there's still stuff from the last thing I did down here, so let's get rid of that. Alright, so now I'm going to go ahead and simplify this. We have 1/8 times quantity 2x minus 3 to the 4th from 1.5 to 0, or 0 to 1.5. So I'm going to go ahead and put 1.5 in, and when I do that, you'll notice that I get 3 minus 3 to the 4th, well that's 0, minus quantity 1/8. Here's the thing, in a lot of other cases that we've done, we haven't had a term without an x. because there is a term without an x, we're going to actually have a value here. So we're going to say 2 times 0 minus 3 to the 4th. Okay? Oh goodness, I still have so much stuff left over here. Alright, so let's simplify this. You have 0 here times 1/8 times negative 3 to the 4th. Okay, well that's going to end up being a positive number here. So we end up with negative 1/8 times 81, which gives us negative 81/8. Well, we need to take the absolute value of this because the area can't be negative. So we end up with 10 and 1/8 units squared. Or positive 81/8 units squared.